Good afternoon, everyone. Welcome to the Visual Sound webinar on teaching coding skills with limited technology. My name is Dana Witzel, and I'm a Visual Sound account manager on the education team. Our presenter today is Corey Freed. Corey's the Visual Sound education consultant. She's a former classroom teacher, and she's both Google and Microsoft certified. She'll be sharing some resources after the call today, so please enter your email address in the chat box so we can send that out to you. And today's session is being recorded. Okay, Corey, go ahead and take it away.
All right. So as Dana mentioned, my name is Corey Freed. So today's session is about coding, teaching coding for your students when you don't really have much equipment at home. So when we're in the classroom, we definitely like to use robotic products. We like to use SamLabs and Little Bits and Spheros and all of these products and toys that can really just help the kids with the hands-on stuff. But what can you do when you are teaching remotely? Obviously, your students do not have SamLab kits at home. Your kids do not have Robotis products at home. They hopefully have a computer of some sorts, maybe have their phones. So that's what we're going to look at today is the different things that you as a teacher can do. Now, a lot of this that we're going to be looking at is cross-curricular. So you can teach these computer skills and these computer coding skills without actually having to be a specific computer teacher. So the first thing I want to look at is what I like to call unplugged activities. And when I say I like to call them this is actually what Codeorg calls it as well. These unplugged activities are the type of things you can do with your students that require absolutely no technology whatsoever. So if you can give your students, like let's for example say that your kids don't have a computer at home and they're coming once a week to school to pick up a packet of work, these are the type of products that you can print out and your students can do at home so that they can still get that computational thinking, the loops, the logic statements, all of those type of things. So the first example I have are the real-life algorithms. And you would want to definitely talk to your students about what an algorithm is. So do I have anyone that would like to put in the chat box or come off of mute and tell us what an algorithm is? Don't be shy. All right. Well, an algorithm. Oh, someone finally came off mute. Okay, go ahead.
Yeah, well, an algorithm is just simply logical thinking, step by step. What comes first? What comes next?
Exactly. Yes. That is the correct answer. Well, the official definition, according to the dictionary, is a process or set of rules to be followed. So basically what you said, step by step. So the most common real life algorithm that we did as when I was a kid was how to make a peanut butter and jelly sandwich. And I remember the teacher would actually, like, if you just said spread peanut butter on the bread, the teacher would take the entire jar of peanut butter and put the jar on top of the bread without opening the jar and spreading peanut butter. Because the whole point of these real life algorithms is to make sure that you don't leave those steps out. So an activity you can do with your students is have them write the real life algorithm for an everyday project that they do. So for example, if you tell them to write a recipe and they say bake it for 20 minutes, but they don't say preheat the oven to 350, well, if they now send the recipe to a friend and say to the friend, try this out, the friend will not be able to replicate the recipe. They won't be able to try the meal. So using these real life algorithm examples is just helping your students see that step-by-step direction. The folding a shirt one is one that I actually really like for remote learning because you help the parents as well, kind of teach the kids how to do some chores while disguising it as a computer program. The other thing with folding a shirt is you can use loops, because if you fold the shirt to the left, then you just do a loop with the negative, and that's folding the shirt to the right. So you're kind of helping the kids see the process of loops, the logical progression, and everything just by writing out the directions to everyday tasks. So the next lesson I have here that is for Unplugged is text compression. And this is something students are actually pretty good at because when they write text messages and they write on Twitter, they're used to already having to kind of shrink what they're saying. But when we talk about text compression in the terms of loops and patterns, And in the terms of computer science, we are talking about how a file that could be like a 500-page book, how they can make that file small enough to send through an email. And that's using compression. So what you can do is give your students, for example, you can see I have If You're Happy and You Know It, have your students take a song that they love. Yes, Jennifer, I will be getting this out to everyone. It will be on the bit.ly that I did not post in the chat yet, so let me post that for you. So the link that I just added to the chat section is it's going to be all the resources, and I will send it out as an email as well. Oops, didn't mean to go ahead of myself. So like I said, the text compression, this is something you can do with your kids. And you'll notice that on the bottom, I have character count because I want the kids to actually see how compression works. And the other thing that you'll be able to do with this is turn it into a math problem. What percentage did you reduce that file by? So if the original file was 417 characters, but by adding even with the key, so my actual song, I was able to reduce from 417 to 16. But even when I add back D, that is a 75% reduction in file size. So think about sending that as an email. I'm sure many of you remember the old days when you went to send a file over dial-up and it would say like 700 minutes remaining. Obviously, kids today have higher speed internet, but the concept is still there. The smaller the file, the faster it sends. So that is how compression works. And this is a great visual for students to see what's happening in the code of the computer. And I just heard someone come off of mute. Do you have a question? If you have a question, please feel free to ask. So the next thing I'm going to talk about is some resources for teachers of all subject areas. Code.org, which is most famous for Hour of Code, has a lot of activities that you can do for students. They have full lesson plans for the teachers, and they also have self-paced activities for students. Everything on code.org does not require any products. You don't require robotics. You don't require a Raspberry Pi, an Arduino, nothing. You can do everything on code.org on the computer. So it's a really good program that is free of charge to teachers and to students so that they can just try stuff out on their own. Same thing with CS First, which is actually part of Google. CS First has free lesson plans for teachers, self-paced activities for students, and the nice thing about CS First is that it does sync pretty well with Google Classroom. So you can assign things in CS First on Google Classroom. You as the teacher can actually see student work. So it is a nice little compromise between just sending the kids off on code.org and trying to create lessons on Google Classroom. So the next program I'm going to show you, this one is actually from Microsoft, and it is MicroBit. Now the MicroBit is a computer processing chip that you can purchase and your students can purchase them. They are, depending on where you buy them, they range anywhere. I've seen them down by $8 and I've seen them go up to about $30 for the exact same thing. So I don't know when you go look for them right now, but I just want you to know that they do range in price. The reason why I like the website though is, as you can see in the picture, it gives you a virtual microbit right there on the screen. So when your students do their code on the right, they could actually test the code on the left. So without having to use an actual microbit, which you might have in your classroom, your students can test their code. Now, when they finally do come back to the classroom, they can come into you and borrow one of the microbits and actually do their project. But this way, again, that visual definitely helps take it a step up from some of the other coding where they can't really test their code and see if their project worked. So SamLabs is the next one I'm going to show you. And the reason why I really like SamLabs is because their programming, there's two different ways to program SamLabs. The visual that you see on the screen right now on the left is a picture of SamSpace, which is their downloadable program. You can turn it to offline, which is going to give you virtual SamLab pieces. So as you can see on the right, I have a button and I have a light bulb, and it's letting us see, well, if you push the button, you're going to turn the light on. Obviously, if you have your SamLab kit and you have the pieces, you can actually turn a light on. But within the program, you can visually see the reactions, the cause and the effect, the loops, the logic, everything. So that's one of the great things about SamLabs. And again, this is a product that when you go back to the classroom, you definitely can have SamLabs. We do sell the kits at Visual Sound, but the personal reason why SamLabs has their own slide on our presentation today is because SamLabs is currently running a global STEAM and code creating competition during the coronavirus closures. And the prizes include prizes for the individual student that wins, along with their school. So if you are the host school, for example, if it's one of your students, you can win a prize for the school. So you can win some of these SamLab kits for your school in September when you reopen. Again, this is a completely free competition. And they specifically said you do not require to have the SamLab blocks to participate. So they have made this competition in a way that your students can participate without any devices. And it is a STEAM and creating project because they want kids to realize that coding is not just the computer part. It's the creative part, it's the logic, it's the process, and it's the problem solving. So that is the biggest thing with SamLabs. I am going to take you out of the slide deck right now and show you a couple of these resources in real time. So the first resource I'm going to show you is code.org because this is the easiest one for students and teachers to react with without having anything at home. So as you can see, there is a school closure link right on there. This is going to help you find the stuff that's easiest to do from remote learning. When you come in here, again, Hour of Code is what code.org is most famous for. And here are a bunch of different programs that your students can do. Flappy Code is one of the popular ones because it's obviously Flappy Bird. And your students can program the background, the birds, everything to kind of play this game on their own. And what will happen is it has videos for them, and then it takes them step by step through programming the game. So they can cause all the reactions, they can cause the what's happening, everything like that. And Jennifer just wrote, my students love the Flappy Bird game. That's why I picked it as the example, because it is one of the favorites of students. So as you can see, the little duck takes you through step by step, attach a block to the when clicked block, press run, takes you all the way through. When you're finished, your kids get a nice little certificate. So if you were doing this on Google Classroom, what you might do is you can assign it to your students and say, finish the Flappy Bird assignment. And then the proof that they did it could be upload the certificate to your Google Classroom. So they would come here, they would type their name, hit submit, and it prints their certificate so that all they would have to do is save the image and upload it to Google Classroom. Okay, so Gail just wrote, it only cut off because of the way the screen was. What if students have done the ones that are listed? I have middle school, they've done all, now doing a dance app. So that's the beautiful thing about this, Gail, is there are a lot of different options and you can find something that works for your students. So as you can see, if you scroll down, it goes from K5 all the way to beyond 12. So there are plenty of different things that you can do with your students, plenty of different activities available. If your students have done everything on code.org, last thing with code.org before I leave is just so you can see right here, they have CS Fundamentals through CS Principles. These courses are actually they're not AP course ready, but they're close to giving you a starting point if you were going to be teaching AP Computer Science. So the other resource, if you have done code.org, is CS First. And again, CS First is through Google. And what CS First does is it provides you with curriculum and resources and just a lot of different things that you can do. So when you sign into CS First, it will ask you the first time if you're a student or a teacher. You log in, your students would log in. This is where I was saying it kind of works really nicely with Google Classroom because since it is Google, it's all the same account, everything syncs up. So it's very easy to use. You create your class and it will actually let you import the class from Google Classroom. and then you can assign things to your students here in CS First. So when you look at the curriculum for CS First, you will see there's a get started and it asks you questions. It has lessons. Here's characterization. Help your students figure out characterization of different things. Using code to describe actions, thoughts, and words. Interactive presentations. We have all seen some of these animated presenting softwares. Well, the kids could actually code it themselves. And then it keeps going on. So you could see like these lessons here are all literature and literacy. Then you have here, it goes to some hour of code type of activities. And it just, as you scroll down, multi-day, it gives you a lot of different options, different things from code.org. So it's just another resource, another great activity. Also through Google is Workbench EDU. And Workbench EDU is technically part of Google, but it is also separate. And what's nice about Workbench EDU is similar to SamLabs, you get that visualization. But what's really nice, as I accidentally just hit login with the wrong thing, I don't have Clever. So what's really nice about Workbench is it has lesson ideas for all different items, but it also has a built-in coding section where you can code both block coding and Java coding. So those are the nice things. And apparently I don't have an account. I am logged into the wrong account. That's why my Workbench account is on my personal Gmail, not my Visual Sound. So if I scroll down just to show you, you have the featured lessons. So you have all different things, plant adaptations, seeing the future. If you go to the channels, you can see different products. So we have Dremel, which Visual Sound does sell Dremel. So these lessons go really nicely with things that we have for your classroom when we go back. We have SamLabs. So all these different things. Here's csteachers.org. And csteachers.org is the National Organization of Computer Science Teachers, and they give you a lot more lessons to do with your students, things that can be done from home. If you were to go to the SamLabs kit, here you would see a bunch of different lessons using SamLabs. Here are some samples of different pieces that SamLabs sends or sells. Here's the different coding ideas that you can do. So all of this is in Workbench. And again, Workbench is just a really nice resource. I am going to log in on my personal account so that you can see what it is. I do apologize that I was in the wrong window. So if you give me 1 second to switch my window. All right, so Workbench EDU, like I said, has built-in coding. And the best part about it, the reason I really like Workbench for teaching kids how to use the different stuff, yes, Workbench is free. So if you wanted to use the actual like robotic pieces, those are not free, but the coding part of it is, and all of the lessons on it are free. So if you come over here to create, you will see it says new Blocky program. And again, this is the thing I love about it, right here where it says devices. You can connect a lot of different products. So you can just use a Google spreadsheet. Google spreadsheets obviously do not require any robotic products. So you can teach your kids the formulas and the functions using a block coding process. You have Sphero, you have drones, you have your MicroBit, you have all your SamLab pieces. So all of this stuff can be put together for one major project. So your students can come in here, they can use a spreadsheet to record results, the Sphero to navigate, they can use the MicroBit to light up and blink, they can use all the different SamLabs all together in one code. And then once they connect all those different products, it's block coding. So they can just go ahead and drag and click and everything like that. You have your if-then statements. And it's just really nice. They can save their work. They can share it to you through Google Classroom. If you click clean up blocks, it just organizes everything a little nicer looking. Yes, there are tutorials, Gail. It has everything is built in where it says lessons. You can find pretty much anything you need with any of the different things. Again, the channels is where you would find the different products. So here's SamLabs, here's Dremel Labs. Again, CS Teacher is the computer science organization. We also have Makey, MicroBit. There's all different things, and they're growing this all the time. All of these companies. So if you go back again, like Makey, SamLabs, Dremel, scroll down a little bit, you're going to see Pearson, which is a textbook company. CK12 is a textbook company. They are all working with Workbench to create this database because they know that teachers want this one-stop shop to go to. So we're going to come out of Workbench now because I do have a few other things to show. So let me go back to my other window. I want to show you the SamLabs competition. So this is what I was talking about that your students and you might be interested in. It is a SamLabs STEAM and coding competition. It is, again, it is completely due to the COVID-19 lockdown, and they're just making all of these different products. So the upcoming session is going to be prototyping. You're going to see it says prototype challenge. There is no requirement to use the SamLab kits for that. They also have it set up so that the kids are going to compete in teams. You want to help your kids collaborate through either Google or Microsoft. So if you're Google, you'd probably be using Google Docs in Classroom. If you're Microsoft, you're going to be using Office 365 and Teams. But your students want to collaborate and solve these problems. They are separated by age for fairness, because obviously a first grader going up against a high school kid would not be the easiest competition for the kindergartner. The high school kid might find it really easy. And the prizes include money for the students, and it will also include SamLab kits for the schools from the winners. They're going to be going throughout the entire month of May, and there's all different stuff. So again, there's 2 different types of challenges, and each challenge is going to be based on what students have access to. So if the students don't have access to a SamLab kit at home, they're going to be able to still participate. As you can see, the prototyping competition even says paper, pencils, markers, crayons, and common classroom office supplies. It is a really great free thing for you to do with your students to help encourage them. So I do recommend you definitely look that up. All right, so the last slide I have on our presentation is just some of the stuff that we do sell here at Visual Sound, because when you do go back to the classroom, this is stuff that you can just incorporate into what you've been doing while they're home. So while you've been at home, the kids might be doing some coding and some different types of projects. When they get back to the classroom, you can use Raspberry Pi, and they can actually program the Pi using their code, and it can do almost anything. Same thing with STEMFuse, which is a curriculum that we offer. It's going to have coding lessons. It's going to have 3D design lessons. Obviously, you can't print the 3D designs at home unless you have a 3D printer in the home. But your students can design it from home, and then when you come back to school in the fall, they can print out their projects. Or I do know that some teachers have been going in and printing stuff on the 3D printers. I know one teacher in New Jersey brought 4 3D printers home from his school with permission from his principal. He's been printing out the students' projects at home and mailing them to the house for the kids. So the kids are designing it on the computer. They're still doing the 3D design and the prototyping, but then the teacher is printing them out and sending them to the kids so they can have their final project. Robotics is robotic kits, and they come from primary grades all the way up through advanced robotics. And what's really nice about these kits is for the teachers, they are designed so that you do not need any previous experience with coding or robotics in order to program, but they are using robotics language, which is what professionals in the industries are using. So it really does help prepare students for being ready to go into a robotic field when they get to college and beyond. So right now it is 2:25. I'm going to open the floor up to questions about anything we talked about today. You can come off of mute to ask your questions, or you can type them in the chat box. Once again, I appreciate everyone who came to today's session. If you have any questions, I'm here. And if you haven't already, please leave your email address in the chat box so we can send you resources and information after the webinar is over. I have students who do not have a strong enough internet connection to do coding online. What would you suggest for them? For students that don't have a strong internet code, I would definitely say that those offline assignments that I showed at the beginning are the type of things that you're going to want to look into. The real life algorithms and the text compression are just the two examples I gave. I would also say, though, that Codeorg has a full section of these unplugged activities. I know for high school, it's a lot different. For elementary school kids, you could actually have the kids kind of use a grid, like graph paper, and design a maze, and then program. And when I say program, I mean just write the algorithm, write the steps of how to get through. Like they could say, move 3 boxes forward, move 2 boxes to the right, move 1 box backwards. So just, it's definitely that computational thinking. It's the thinking about the logic and thinking about loops. If you're doing repetitive things, do you have to write the steps over and over, or can you say repeat step 1 to 3, then do the next thing, repeat steps 1 to 3, then do the next thing? So for offline and for lack of internet, the best thing you can do is just get that computational thinking and the logic. Logic is the biggest thing when it comes to coding. You can give them Sudoku puzzles. I know that sounds kind of crazy, but even something as simple as that is going to help their minds develop that process and that thinking. So when they do come back, they're a little bit ready to understand the concepts of, if this happens here, this has to happen here. Or if this is sitting here, obviously this won't work here. All right, Gail wrote, I used CS first, but students had issues with saving passwords. So CS first should just use their login with Google. How do you access visual sound unplugged from visual sound? We actually do not have a visual sound unplugged. So the activities that I listed, the first activity, the real life algorithms, that's just one that a lot of computer science teachers use as an introduction. The text compression one was from Code.org, but I turned it into an unplugged activity. So the one on Code.org actually has a widget, so the students can, the widget calculates those percentages. The widget, it does everything. The kids kind of just click and say, this is repetitive, make it this emoji. This is repetitive, make it that emoji. So this example that I did for the offline is just showing how to do it if the kids don't have the computer access. On code.org, though, because this might be helpful for Jennifer, there are PDF worksheets for the text compression that you can print out for those students with lack of internet. So for the CS first, where you were saying they're having trouble saving their password, again, it should be a login with Google options. So they shouldn't have a separate password for it. So if they go here and they click I'm a student, create a new account, they have to enter their class code the first time. Oh, you are right. The students do need to have a username and password. That is really interesting, Gail. It has been a while since I used this with students, so I apologize for not realizing that. You would think if logging in as a teacher uses the Google login, so would the students. So if the students are having issues remembering their password, I would just recommend that you tell them to write it down on a piece of paper somewhere, but not to save it in their, like, don't save it in their email account. Don't save it as a Google Doc. You obviously wouldn't want the password somewhere where other people can find it. But that would be my recommendation.
Yeah, Marianne, why you sit down? Muhammad, get up and help clean up. I told you to get your math book, Muhammad.
So I apologize. I just muted somebody. There was some background noise on their microphone. So yeah, unfortunately, remembering passwords, that's just one of those things students have to figure out their own best practice for remembering them. I think that mnemonics, that's how I remember my passwords. I normally will like think of an entire sentence and then just take the first letter of each word, and that's how my passwords appear, very, very random and not random at the same time. If you do want to do a lesson with your students on password security, one of my favorite lessons that I used to do with students was always just the word password. So Gail just wrote, they give you a username and password. I have them write it down or snip it. Oh, okay. So when you add them to the class, it gives them. Yeah. So like I said, writing it down, if they can't change the password, that makes sense. Just to show you though, that thing that I was using. When you say what website are you using, we are currently talking about CS First, which is through Google. I am just going to add a blank slide to this presentation real quick to show you the lesson that I tend to do with my students when I was in the classroom on password security. So what I would do is I would start with the word password, and I would give the students 2 examples of the word password. So as you can see, and I'll make the font a little bigger because I just realized how small it is. So as you can see, I would give them the word, and then I'd give them these 2 examples and say, look how I now, using cap sensitivity and symbols, how I just changed that one word into 2 different types of passwords. And then I would make it a competition and say to the kids, all right, take just the word password and see how many different passwords you can create with it. And that would be the lesson that I would do for that. Another thing that I would do for the students is pull in some math to it. So I would actually have them think about the how many different combinations they can make. And we would start with, okay, let's just look at the alphabet. There's 26 letters. If I ask you to make a 5-digit password using 26 letters, how many possible passwords are there? Now let's make it cap sensitive. So now instead of 26, you have 52. So then you have how many possible passwords. Add in your numbers. Now add in your symbols. Then notice that most websites require 8 symbols or more. And I give them the math and they just start to see the numbers grow and grow. And it helps them realize how many passwords they can create with such a simple concept. So that was always when I was in the classroom teaching computers. That was probably normally during September, I would do the password lessons, but we would spend at least 2 to 3 days on just password security and all of that type of stuff. I am glad this was really helpful for you, Jennifer. Does anyone else have any questions? Again, you can come off of mute if you would like to ask them. You can type them in the chat box if you don't want to come off of mute. It is totally up to you.
Are you having any other meetings today?
This is the last session for today. So when this webinar is over, there are no more meetings. At least not for our webinars. If you go look at our website, the link to our website has the schedule for the rest of this week. On Wednesday, we are repeating the virtual field trip session. And on Friday, we are doing a session on screencasting, different options on how to record your sessions, different ways so that if you want to pre-record and make videos for your students, you have a few options. So as you can see with Google Meet, I am recording our webinar, but there are other programs that you can do recording through. Smart Notebook has a screen recorder, PowerPoint has a screen recorder. So we're going to walk through some of the different programs just so you can compare and see which one you are most comfortable with for personal use. All right, well, again, I thank you all for your time. I appreciate that you all came to today's session. I hope you got something out of it. If you do have any additional questions after the webinar is over, you are more than welcome to send me an email. My email address is listed on the top of the bit.ly. It is cfried@visualsound.com. I'm going to post the bit.ly in there again, just in case you missed it at the beginning of the chat. All the resources from every webinar I have done so far is on that Google Doc, along with recordings to all the previous webinars. And this recording will probably be posted within the next hour, maybe 2 hours, depending on how the internet is responding today. Sometimes YouTube does take a little bit of time to process.
Thanks, Corey. That was great.
Thank you.